As we discussed in this section on one-dimensional motion, an object that is in the process of slowing down or speeding up is undergoing acceleration. So, what is the relationship between force and acceleration? Newton's second law gives us the answer. It states that the total net force acting on an object is equal to its mass times its acceleration. Notice that both the net force and the acceleration are vector quantities. What does net force mean? It is the vector sum of all the forces acting on an object. Newton's second law is probably the most important equation in mechanics. The units of force are newtons. 1 newton is equal to 1 kilogram, meter per second squared. Let's look at some numbers. According to Newton's second law, how much force is needed to accelerate an object of mass 10 kilograms at a rate of 5 meters per second squared? The answer is 50 newtons. Now it's your turn to answer a question. If we exert a constant force of 100 newtons on a 5 kilogram object, how fast will it accelerate? Correct. The correct answer is obtained from the equation acceleration equals force divided by mass, in which force is equal to 100 newtons and mass is equal to 5 kilograms. From this, we find that acceleration equals 20 meters per second squared. Often, forces in nature are not confined to one dimension. Therefore, to evaluate the net force and the net acceleration on an object, we need to treat the forces as vectors. Let's start with a simple example. Let's assume that two people are each pushing a 10 kilogram crate with an equal force of 100 newtons, as shown. In our coordinate system with x to the right and y toward the top of the picture, person number 1 is pushing with a force of 100 newtons in the positive x direction, and person number 2 is pushing with 100 newtons in the positive y direction. The net force is therefore given by the vector sum of the two forces. Since Newton's second law states that F equals ma, the acceleration is given by the equation a equals F divided by m. The acceleration vector points in the same direction as the net force. Plugging in the force and the mass, we obtain the acceleration of the crate, which has components in the x and y directions. To obtain the magnitude of the acceleration, we add the square of the x and y components of the acceleration vector and take the square root. The answer is approximately 14 meters per second squared. To find the direction of the acceleration, we take the ratio of AY and AX, which is equal to tangent of the angle theta. The answer is theta equals 45 degrees.